to find out there's a Rayleigh distribution and a Maxwell-Boltzmann distribution that comes from it. A lot of notes today, but I'm going to try to get to the point. You don't need to write this down, but just for everybody's sake, when we talk about a Gaussian distribution, or any Gaussian type of event space, what we're always talking about is some density function that's given as 1 over the square root of 2 pi, sigma x, that's the standard deviation of the actual, of the statistics or the probability density distribution of f of x. exp of minus, and here it's x minus x bar squared over 2 sigma x squared. And that is the density function, and it's valid from minus to plus infinity. And a couple of things that are real important to know about this. The first, I think everybody does, is the integral of f of x. You don't need to write this down. From minus infinity to infinity has to be 1. That's the first thing. The other thing that's important is that for that density function, the area below the mean is exactly equal to the area above the mean, and it's exactly equal to 1/2. How many understand that? It has to be. This is called a bell curve, and if you actually look at what it looks like, f of x here, and you find the mean, whatever the mean value is, it is the most probable value as well. You'll get a bell curve like this. Can everybody follow? This would be x, and this would be f of x here. Everybody with me on this? Now, the area under here is 1/2, and the area here is 1/2 also. That's important to know. F of x can never be negative for any density function that's legit, but for this one, it's obvious it isn't. And there's things called tails on this one. So as it gets further and further away from the mean value, it's going to 0 quickly. Y'all follow me on this, class? Now, when we're dealing with values way out here, if you try to calculate that, for instance, this right here, if we try to calculate something, let me just give you a concrete example. All that I've just said is basic, that I think everybody knows. If you've done the homework, listened to me before, and also read any of the book about this, you'll realize that. Now, what I'm about to say is something very important too. When we talk about f of x, that's the cumulative distribution function. Is everybody familiar with that? And what it means is this. It's an integral from technically minus infinity to some point x of 1 over the square root of 2 pi sigma x, and it's exp to the minus the quantity x minus x bar squared over 2 sigma x squared. And actually, I should put a prime there, dx prime, because you can't have a limit, or you might say the limits of integration have the same symbol as the kernel of integration. In engineering, we do it all the time because we know once you do the evaluation, you have to plug that in. But I mean, if we wanted to be rigorous, do y'all follow me in this class? Also, there's something called, and he calls it q of x, and that's the integral from x to infinity of this, of really, I'll just put down of f of x dx. And that's just the remainder, right? And you can see one thing for sure, that f of x plus q of x has to be equal to 1, because that's the extent of the integration. Y'all follow me? Now, there's a few other things about this q of x, and it's important you see this. I want to do this in a way. Well, I'm going to go ahead and talk about how he lists some functions that he's going to get rid of the standard deviation and the mean in these functions, their normalization. And And one of them he calls capital, I'm calling this Q of X, and I think that's consistent with this book's definition. In the actual, in the Cooper and McGillen, in that book in chapter 2. Do you remember seeing this class or not? You don't remember seeing it? Well, it doesn't, you don't have to use Q of X, but I want to show you something. So what he also does is he says, in his book, he's going to list two functions that have to do with normalization. And one is a capital phi of u, and that's equal to the integral from minus infinity at 2u of 1 over the square root of 2 pi. Here sigma x is gone. It's exp to the minus, I've got to have a different symbol here. I'm going to use v squared over 2 dv. And what happens here is this u becomes x minus x bar over sigma x. So this is kind of a way, if you use the tables, if you look at the tables at the back of Cooper and Millen, I think Chan has tables too, but I didn't actually look at Chan's book on this. You're going to see he has tables, lookup tables. So if you know what the standard deviation is, you know what the value of x is, that you're looking for the probability of less than a certain point, and you know what the mean is, you can calculate this value. Then if you go in his tables, he'll have this with an argument, and then he'll have this giving you the value. And what he does is has columns of this thing, because he breaks it down into, say, if u was 0.01, 0.011, 0.012, and y'all follow me in that class? It's just basically something that allows it to be an interpolation of what the value is of that. And you can use that. Y'all with me on this one? There's also something that he calls a phi, all right, but it's small phi. He uses this as small phi of u, same value of u, and it's the integral from x to infinity of, and he has these tables provided, of 1 over square root of 2 pi exp to the minus, and I better do v squared over 2 dv. So he has, this type of information is useful if you're going to use tables. Back in the old day, before calculators got so powerful, they did this. All of you have calculators here today, don't you? Everybody? On your calculators, how many looked up the statistical packages available? Did you get it to work?
Yes.
How many got it to work? I'm curious about this. All right, because that is the thing you need. Now, there's also something that I'll be talking about. It's not just an inverse thing, a direct search. For instance, if you know x, sigma of x and u, and you want the probability of the event being up to that point or less, x being to that point or less, then you can do basically evaluate that integration through your statistical packages. However, if you know the value of the probability, and you have the mean and standard deviation, y'all with me on this now, and you wanted the value of x that would do that, it's called an inverse search. Y'all with me on this class? In other words, if I give you the probability of this event occurring, and I ask the value of x that would allow that, that's an inverse search. It's still on the tables, you're basically doing the same thing. You're hunting and pecking for values. On your calculators, you'll have an inverse search, and I think, can you tell me if I'm wrong? On a lot of them, is it called p norm? Is that the function? And then q norm is the inverse? I don't know for a fact, because these are standards that I saw.
For me, it's normal C after that.
That's cumulative distribution, right? Normal
Yes.
C? And what's the inverse? Is it P, is it Q norm?
Well, I was just using 1 minus normal C.
No, that's just that's the remainder of the integration. Suppose I gave you a probability, a standard deviation, and I gave you a mean value. To get the value of x would be an inverse.
Yeah.
So I'm not sure what it's called in your
Mine
calculus.
just says in normal.
Was it?
Yeah, mine says in normal. I
Inverse.
Yeah.
Okay, well, all right, I normal, right?
Something in
Yeah.
INV, yeah.
INV normal, okay. That's perfect, makes sense. I want to make sure I say that. Got one more thing to cover before we do problems. 1 second. I covered the moments. We're going to do a few of those, but I'm going to come back to this. And that. Got a lot of notes. All right. Well, in the book he has something. Now I'm gonna put this down because there's actually there's a couple things I need to do. First, I want to finish my thoughts on this particular event space and stuff. So let me erase this and I'm going to complete this idea. So I'm going to work, now I'm going to address this with the, I'll use this, and what I'm going to do is talk about a couple things you have to appreciate. We're going to get rid of the norm and everything. We're going to assume U is equal to X minus X bar over sigma X. So we're going to assume this, and therefore, if you look at this right here, it's going to be equal to the integral. Actually, I got X. This would be U here. But I want you to see this. This would be U to infinity of 1 over the square root of 2 pi exp to the minus, call it v squared over 2 dv. Now, for this one, you can assume it for all intents and purposes. Here the standard deviation is 1 and the mean value is 0. That's exactly what I'm showing you right here. Y'all follow me? And the reason you can get away with this is we've done this as far as the limits of the integration. It'll work. If you actually do this and prove it, if you go ahead and take this right here, and then you basically, for U here, you put in that and go through the rigmarole, you'll find that that's what you get. It really does work. But anyway, what I wanted to show you, if this is, call it U, right here, and you look at this, we have a curve like this, and it's real important to appreciate this. Y'all with me on this one, class? I'm just trying to show you. Now, if you pick any value, say here, and I'll just call this minus U, right? The area under here would be the same as the area under here. Can everybody follow me? Arguments of symmetry. How many see this right now? Now, the reason I'm saying that is, that means that for that function, I'll call it phi of U, what that really is, that's the area under here, right? Well, the area, actually, I should say it this way. Phi of U is the area up here, right? So if I take a look at this, and I know if I integrate and I let U, basically if I say from U goes from minus infinity to infinity, it has to be 1, right? So I have 1. So if I wanted this area here, right, I would say 1 minus phi of minus U would be equal to this. It's the same areas, basically. Do y'all follow me in this class? Basically, total area is 1, and if I took 1 minus and I'm calling it phi of minus u right here, that's going to be this area or that area. And that's, he has this in his book. Just realize arguments of symmetry are very powerful in this case, and we'll get to this reason why. I'm saying all of these things to sort of set the stage for some problems. Symmetry is a powerful tool, remember that. And always remember the area, if you find the mean, the area below is 1/2, area above 1/2, or the probability of the event being greater or less than is the same, exactly 1/2, and that's important. So next, after all that, I want to talk about, well, if we look at this distribution, and I'm going to talk about f of x, right here, where basically, I'm going to use f of u, and here we're assuming u is equal to x minus x bar over sigma x. And you look at this, I'm calling this u and f of u in this direction, and the tails look like this, right? So if I want the probability right here, I want this area here, but I'm going to say for u large. So large values, say 3 standard deviations higher. Can you all see this is going to be a steadily decreasing area as u gets larger and larger? Your calculators will render the wrong answer if you get about 5 standard deviations away. It will. If you take 1 minus the f of x, 5 standard deviations, in other words, that area, because I did this last night actually with math and I get the wrong answer, you're going to get an answer that's wrong. So in the book he talks about this, and he says what you can do if you're getting large values right here, and there's a proof for this in Cooper and Millen in the chapter 2. But you can get something where you're going to approximate this q right here of u, and you can say it's 1 over 2a squared. Let me put this down. I'll show you where this is in the book. It's going to be an exponential I want you to be aware of this because this does come in handy if you run into extreme cases, and sometimes you do. He actually uses the argument a, but it doesn't matter. And he has it 1 minus 2 over a squared, and then it's going to be times 1 over a square root of 2 pi exp, and it's going to be, yeah, I'm going to make this an a as an argument, and it's going to be minus a squared over 2. So this is going to be, an a is equal to u, basically, it's an argument. So u equals a, and or a, I should say a becomes u, and a is much, much greater than like 4 standard deviations of u, or basically 4 standard deviations of u, which would be 4, greater than 4, because it's a normal standard deviation. That formula works. So this is 1 minus that. And it'll get you the right answer. It asymptotically approaches the correct value. And you can get it down to 10 to the minus 12, 10 to the minus 14 kind of values that your calculators won't be able to get. So just remember this. We'll see examples of this. Now for the problems, first, does everybody, I'm trying to give you an appreciation for some of the tools available and things to consider before I just jump into these problems. Let's see. The fourth central moment is on page 72 if you want to write that down, but I posted the moments, did you say that on OneNote? For up to, I think, fourth or fifth central moments, right? And also the fourth moment, because you'll be asked for this kind of stuff. I will, some of these I'll provide, and I'll be real honest with you. The only thing I expect you to know is like that all the odd central moments are 0 for a Gaussian. Y'all with me on this? And for the even central moments, and I hope you remember this, for the odd central moments will be 0, and I put this down last time. So when we take a look for Gaussian to the nth power here, and we want the moment, it's equal to 0 for n odd. And if you take a look at this, and we want, that just means the average, the bar over, or the average value. This is going to be 1 times 3 times 5 times n dot 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 all the way up to n minus 1 sigma to the nth, and this would be for n even. Now these are central moments. Does everybody follow me on this? This one you need to know. Now from that, if, for instance, if you take the third central moment right here, it's odd, you know that goes to 0, right? If you want to, you expand that, and that's basically x minus x bar to the nth power, right? So if it's 3, it would be x minus x bar squared times x minus x bar. Now just listen, it's not hard to understand. So if I take x minus x bar times x minus x bar, I get x squared, right? Minus 2x x bar, and it would be plus x bar squared. Then you multiply that again by x minus x bar to get the cube. And you know the whole thing's 0 here, so you put everything on the other side, you can find the third central moment if you need to that way. Follow me? Third central moment is not, or third moment, pardon me, is not 0. Now, let me get through that a little, maybe I was too quick. And now I want to do some problems, because that's really where you're going to see a lot of this stuff. You can bring it all out and have your calculators ready. All right, got that down, got that. I want to do exercise 2.5.1 in the book. And I think I put the answers down, didn't I? Next to the problems? Yeah. Just the answers. I don't know if I put all, I don't think I put the word there. So this is exercise 2-5.1. All right. Ask you to read this in 1 second. Let me first clear the board. Get your calculators out. Make sure you can do these kind of problems, I say effortlessly, well, with a minimal amount of concern. They should become obvious how you do these problems. So for this problem, what does he say?
A Gaussian random variable has a mean value of 1 and a variance of 4.
1 variance of 4, that means standard deviation, right, of 2. Everybody with me on this? Go ahead.
And then he says, find the probability that the random variable has a negative value.
X less than 0, right? Well, that's really going to be what? F of x. Here I'm going to put down the value of x here first, then the mean value. And so normally this is the way I do it. I put the mean value, then the standard deviation. This is, I've constructed this in your calculators. Would you please try this problem? In your calculators, you should have the equivalent of this. where this is the cumulative distribution function, I'll put it right here, and you will have it, I think it's called C norm, f of x, x bar sigma x equal to the integral from minus infinity to x of 1 over square root of 2 pi sigma x, here it's exp minus the quantity x minus x bar squared over 2 sigma x squared dx. And these are primes, by the way. So that's what I'm evaluating with my function. And that is the cumulative distribution function. Do you agree? Now take it out. If you do this and plug the values in, so here, for x equals 0, the only thing I'm going to do is put 0. X bar here is 1, right? And sigma x is 2. And I have the value, I think. What I got is 0.309. If you look in the book, that's actually, he has these answers, but they're not in the order A, B, and C. It's like they're scattered. They have 3 answers, they're scattered. Can you get your calculators out? Do you have a calculator that works? Can you make sure you can do this? I want to make absolutely sure everybody can do this without any problem. And if you have problems, let me know now, and we'll resolve them. Because
Hit second, and then click data, and then,
Yeah, for the standard register.
and then go over to distribution functions, and then click 2.
did you get it?
And then you can plug in your mean
Okay.
sigma or pi.
Did you? Still work. Make sure, if you don't know how, don't worry, we're gonna make sure you do. Otherwise, I'm gonna have to provide tables. And if you can avoid tables, avoid tables. That's my thoughts. What kind of calculator?
TI
84. 84 should do it, no problem, but did you get the right answer? Do you know how to do it? Does anybody have an 84?
Yes.
You do?
It's not, you go to the.
Why don't you just pop up and show? Just get out of your seat. I'm trying to, I gotta resolve this now.
So-
Because I'm not gonna provide
You
tables.
hit second, go to distribution, and then normal.
All right. What's,
You're
what they're
able to
doing
set
there,
all
Jack? What's
limits up to
second?
0
Um,
over
that's
that.
it.
Find the probability that the random
That's
variable
the
has a
mean,
value
the
between
other,
1 and
and
2.
you just hit paste, enter.
Everybody with me? Now,
Um,
several ways to do it, but
You
I
want to
think
do
if we're doing a
-1
cumulative
times 10
distribution function, like most of them,
Yeah.
it would be the
For
cumulative
the lower, that's-
distribution
That's
function.
the representation.
F of x of 2 minus f of x.
And then it's
of
0
1.
to
Does
0.
everybody
And then
agree
0
with
for
that idea?
the upper, yes.
Okay, thank you.
Y'all with me? I want you, did you get the right answer? All right, now for this, I mean, you all agree with this. I didn't put the mean and the standard deviation, they're implied, right? So for this one, what I got, I think I wrote it in there, is 0.181. I think that's right. That's what I got. Could you check and see if you get that?
I got 0.191, but I don't know.
It is not there. Hold on, maybe I can't read. Is it, what's the answer in the book? See, he has answers now, they're out of order, it's 0.11.
Where do you find the answers?
See, right at the bottom? Feel right here?
Oh, shoot.
0.191.
Okay.
Pardon me, I guess my 9 and 8 became 0.191, sorry. That's on me. Can't read my own writing. I guess that is a 9, my bad. Did y'all get that? I want to make sure. Anna Grace, did you get that?
I did.
Did you get that? Did you get that, sir?
I did not, I don't know what I did.
All right, what kind of calculator?
TI 36X.
Anybody got a
The
36X?
36X Pro, this one?
Yeah.
Just hop back there. Elisha, grab the book. Figure it out now. If you don't do this now, I promise you, Thursday night you'll go crazy. Because this problem's gonna get more complicated. I'm just trying to help you, because this can drive you out of your mind. There's little things. At first, do we all agree with that?
Did you use the right thing for the first one?
All right, next part.
The probability that the random variable is greater than 4.
Here, it's x greater than 4. Now, we're getting to the point where we might have to do an approximation, but we're not there yet. When we think about standard deviation is 2, we're not more than a couple standard deviations away. You all with me on this one, class? So for this one, it's going to be really 1 minus f of x of 4, right? That would be the area greater than 4. You all agree with that? Because the cumulative distribution function starts at minus infinity, integrates that whole f of x up to the point. So what do you get for that? If I can read my writing, I think you should get 0.067. Please try that. Now it's going to be approximately that. There will be, what did you get?
0.067.
Anybody in the back?
0.0668.
All right, it's close enough. I want to make sure, because you're going to get a quiz where you have to know how to use your calculators on Friday.
I didn't do, like, is it the same thing if I just did from 4 to infinity?
Yeah, if you do an integration.
Yeah, okay.
But I mean, why, don't you have a cumulative distribution function?
Well, I just plugged it in.
Well, okay, well, wait a second. You can say where the limits are? Oh, okay, if you can say where the limits are, yeah,
Okay.
just go
So
from
I'm just plugging in.
4 to infinity, sure. That's a no-brainer. That's the Q function, basically.
Oh, okay.
I mean, it's, yeah, if you can do that, just do it. But you gotta know how to do
Put
it.
this on the quiz.
We're not done yet. We're just warming up. First I gotta make sure you can do the basics before we start going on, all right? Everybody with me? Now your calculators actually might be able to take the moments of this too, I'm being honest with you. I think they can, but I'm not certain. There's ways to do this. I just don't know how sophisticated you are. And did you all get that? Okay. Okay. Next, I want to do 2.52, I think it is, just next one. Yeah, I'm doing these sequentially for a reason. I want to make sure everybody follows me in this. So 2-5.2, go ahead. Elijah.
It's asking, the first one's the 4th central moment.
Okay, now these are things, central moments, right? Hear me? Your calculators may have the ability where you just enter the moment you want and they can get it, but it's a central moment. So what did I tell you? If n is even, right? So x minus x bar to the 4th power, please watch this. We have x bar, right? It's a central moment, right? So that means if n is even, hear me now, right? Put the formula, I think I erased it already, but that's going to be simply what? 1 times 3 times, well, here n is 4. Remember there's an n minus 1 here? That is 3. That's where you stop this. Y'all with me? Remember the form for central moments, if it's even, it's x minus x bar to the nth power is 1 times 3 times 5 times n minus 1 sigma to the n. That's n even, right? Do y'all remember that? All right, so here n is 4. It would be 1 times 3. You don't write anything else. All right. Then you put sigma to the 4th. So that's really 3 times sigma squared is 4, right? Squared, or 2 to the 4th, or times 16, and that's 48. You agree with that? I mean, your calculators may have the ability to do this straightforward. Does yours, Elijah, or not?
It might, I haven't found it.
See, I don't know. I mean, you can do if you're actually doing, if you have the ability to put the limits of that, and if you can put a multiplier there in front of it, like inside the integration, then possibly can, but I'm not sure. Okay, so y'all with me? Is that an answer, by the way?
Yes.
Okay, that's it. And what's the next part of that?
The fourth moment.
That's the one. So this is gonna be the fourth moment. Now, I would not ask this. I would not ask this on a quiz without a formula. But the fourth central moment on this one, I think I provided all those, right? Those moments. Remember the expected value of higher order moments? You all remember on OneNote I gave those to you? I posted them or not? You do. Anybody else see them? You take a look on OneNote. I think it's the last page, and it says moments of Gaussian functions, both central and actual moments. And for that one, for the fourth central moment, this is the one that is kind of a weird one. It's actually going to be 3 sigma to the fourth. Take a look and see if you see it. Sigma x to the fourth plus 6, and this is going to be, I think, the mean value squared, sigma x squared plus, and then it's going to be, I think, the mean value to the fourth power. Let me see if I've got that right. Yeah. Y'all follow me on this? Do you see?
Oh, did you just distribute the, I'm sorry, where did you get that? Where did you just do?
This formula, if you wanted to get it, here's how you get it. You can get it from this. I'm going to just show you. I'm not asking you to do this. It takes a little while. I've done this. So if you take x, don't worry about writing this down. Just let me go ahead and do it to the fourth power before we take the average value that I'm just showing you, right? Now go ahead. First take, this is really x times x bar squared first, and then that whole thing squared. So that's going to be equal to x squared minus 2x x bar, and it's going to be plus x bar squared, and that whole thing has to be multiplied by that. Look at this. X squared minus 2x x bar, and it's going to be plus x bar squared. I'm just going to tell you this. Now, I haven't taken any averages. Can you all follow me what I've done here? This would be that to the fourth power. With me? Now look, that's even, right? Even times even is even. You're going to have an x to the fourth. This right here is odd. You see that? Odd times even is odd, right? That goes away. Then, that is a constant. Do you agree with that? X bar? Constant times x squared is even. That's going to remain. And you go down the line and you get the terms that remain, because you're going to do an average on this one, right? And if you take odd times even over the extent, you got an odd function, it will be 0 would be the average. However, anything that is even you have to worry about. With me on this one? After you do the whole thing and combine terms, you get back. But it's a pain in the butt to do that. Y'all with me?
Like distributing.
Yes, once you go ahead and do that, the highest power over here, it's x squared times x squared would be x to the fourth. That's this one. You break it out to the other side. All the other stuff you leave on the other side. You cancel the ones that you need to, and that's what you get. I'll just tell you this much. This is not my favorite thing to do, but if you look at this, I know I got x squared, so I got it. And I know this is 0, so I get x to the fourth bar. Then I got this, x squared times this, that's odd. That goes away. This times this is even, so I have to take plus x squared, and this is just x bar squared. That. I know what that is right there, because that's sigma x squared plus x bar squared would be that x squared. Do you all see that right there? X squared, right? Just x squared bar. The expected value of x squared would be sigma x squared, right? Plus x bar squared. Y'all with me on this? It gets a little confusing. Then I come down here, this times this is even, that's it. Finally, this one's odd. Odd times even will be odd, right? The average value of that will be 0. Then I got even, so that means I have plus 4x squared, and it's going to be quantity x bar squared, and I have to take the average of that. Then I have this, that's odd, that's a constant, so that's odd. Don't have to worry about this. For this one, that's just a constant, so it's gonna be plus. You can see how I don't like this. X squared right here, X bar squared bar, constant times this, that's odd, nothing. And then it's gonna be plus X bar to the 4th power. Can you all follow me on this one? I'm going kind of quick, but I'm using the odd even thing to get to the bottom of it. How many are with me on this one? Can you say what I'm doing or not, right here? If you can't, don't worry, it's not that big a deal. That's the formula. But this is how you get it if you want. So I come down to here, and let me just show you what I'm gonna do. This is only one time I'm doing this. I'm not gonna keep doing this, especially like for the 6th. If you want n equals 6, x minus x bar to the 6th power, it is a pain in the butt to expand that sucker. But there is a form that it repeats, I believe. So if I come down to here, this is the one I want, so I take it to the other side. I'm gonna leave it like that, don't worry about the signs. This one right here, well, the x bar squared is a constant, so x squared here, I can say that, let me do it this way. This will be equal to sigma of x squared plus x bar quantity squared times sigma x squared plus, and this one is gonna be 4, and it's x bar squared, and this is gonna be sigma x squared plus x bar squared plus, and I should have factored these things and got that and that, because that's going to be to the 5th power, so I'm just going to make this a 5. And finally, plus x bar to the 4th power. Let me see if we got all that. Break all this out, but that's how you would do it. Yeah.
So does x have like a value, because we're working with x bar, but like if you didn't cancel out all this?
No, but look, whenever you're talking about a central moment, that's a central moment, right? What you're really doing is integrating. Technically what you're doing, what that means is if I have x minus x bar to the nth power, right, bar, that means you're actually taking the integral from minus infinity to infinity of x minus x bar to the nth power, and then it's going to be times f of x dx. Right? So that's what you're doing. Y'all with me? No.
So if you, would you end up with like obviously there where you like distributed and did your math, you didn't end up with like an x in your final, like where you most of it, but if you would
No, it's just the moment, and the moment has a value that's numerical. You don't have a function of x.
Okay.
Do y'all follow me on this? Moments, if you have f of x, a distribution function, you get a moment of it, it's a singular value, it's 5.
So if you're doing this, and you end up with a function of x, you've probably done something wrong.
You can't though.
You can't. Well, like if you did it wrong, you may.
Well, I mean, look, see that right there?
Yeah.
When you distribute the whole thing, right? Just take x minus x bar squared, or x minus x bar squared. When you go ahead and break that out, you get x squared, right? Plus or minus 2x bar x plus x bar squared. Well, and then you have to take the average. The only thing, the average of x squared, right? I'm trying to say this in a way. All those things have numerical value when you're talking about an average. everybody understand? They can't be a function of x. Like, look, when I do this, right? See, minus infinity to infinity. There's nothing in here that's a function of x when you're done. In order for it to be a function of x, this limit would have to be like x. You follow me? There's nothing. This is going to be a numerical value. That's what it's going to be. That's what it has to be.
And
Follow
also,
me?
out of curiosity, says, just from your notation, is the mean squared the second moment of x?
Yeah.
Okay.
What it is x squared bar.
Yeah, so if this,
The bar means an average, x squared would be the mean value. And that will be equal to sigma of x squared plus, it doesn't matter, any distribution. That will be it, period. With me?
like,
Okay, back to that problem. Is there another part to that problem?
It asks for the third central moment and the third moment.
Okay, first, what would the third central moment, go back to this. If n is odd, right? Third central moment would be class? Zero, all right? Then ask for the third moment. Now, you can, I'm not gonna ask for the third moment without providing the formula, but you can take this, right, and multiply it out. You can take, so if you have x minus x bar squared, I'll do this, and I'm not gonna break it out, so x minus x bar squared would be x squared, right? And then it's gonna be plus x plus 2x x bar plus quantity x bar squared. You can see why that mu for the mean makes it a little easier, because the mu would be a little more obvious. That's a 2 right there. Then I have to multiply that whole thing times x minus x bar again, right? This would be the third central moment. Do you agree with that? And if you do that, I'm going to take the average in a second. What do we get? So then you get x cubed, that's the third moment, plus 2x squared, x bar, I'm just multiplying x times everything, plus x times x bar squared, minus, I forgot that minus sign over that one, minus x squared, x bar, minus 2x x bar squared. And finally, what do I get? Minus x bar cubed. We might as well just do this 1. Do you all agree with that, class? After I multiply it up? With me? Now I need to take this, an average of the whole thing. Okay, I know on this side it all equals 0, right? And basically what it is this. Those are added terms, so I can just do this. It's the average of this, plus the average of this, plus the average of this, plus the average of this, this, and this. It's the average of all of them. Do you agree with that? If you have function of x plus g, a function of y, and you want the average, just the average of x plus the average of y. If I do that, it's all equal to 0, so I take this to the other side. It'll be minus x cubed bar, that's the third moment, right? And then over here, I'll get the minus signs first. For this one, I got x squared there. Anytime I see, that's the x bar is a constant, right? So let's see what this comes down to real quick. Unless I've done something wrong. This would be equal to 2x bar, and then x squared would be sigma x plus x bar squared. Y'all follow me what I'm trying to do here? Let's see, the next one is going to be plus x bar squared, and then the average value of x, so it's really x bar cubed. And then it's minus before I do, let's see how many things you can actually mess with here. I got that and that, means that goes to 1. Unless I messed up. Okay, here, and then that's a minus, so this becomes a minus. And this becomes a plus. And I'm curious about this. I know I've calculated this yesterday, last night. So what was X bar again?
1.
It's 1.
Oh, it's 1.
Alright, so in sigma x, sigma x is what? Sigma x squared is
I guess sigma is 2.
4, so it's gonna be 4 plus 1 is 5. And this is plus 2. Then x bar is 1. That doesn't make sense. I must have a minus. Is it 3 or minus 3? I'll tell you what it is, because I did this. It should be 13. Huh?
13.
Yeah, but I think I did somewhere. So the u cubed, or the mean value cubed, plus 3u sigma squared. Somehow in there, I think anyway, that would be expanding the whole thing, but this should be, at the end of the day, there's a formula. After you do the whole thing, you get u cubed, or the mean cubed, plus 3u. So it's the mean value cubed plus 3u, and this would be, I believe, sigma x squared. Must have got that wrong. Yeah, and that mean value is 1 plus 3 times 4, so that's 13. You can, I mean, expanding these things gets a little irritating, but that's what it'll come to. Follow me, class? And you gotta watch your negative signs, and I probably had a negative sign somewhere that I didn't account for in there, trying to get this calculated. Anyway, that's how you would do that problem. Next problem I wanna do is problem 2-5.1. Now, these are homework, right? I want to try to get through these things because it's important that your calculators can do this.
You just did 2-5.
Pardon me?
Did you say 2.5.1?
2-5.1. It's in the OneNote. You all see that, class? Did you see it, Jim? All right, that's the one I want to do. So go to the back of that chapter and let's go through this. I think the best way to do this is just see the problems work. Actually, I have a moment's left. All right, 2-5.1, these are problems, go ahead.
A Gaussian random voltage has a mean value of 5 and a variance of 16. First, what's the probability that an observed value is greater than 0?
Well, this is straightforward, right? Now, take out your calculators, make sure you can do this. I know for myself, I have this down. It's just f of x, and here it's 0, and the mean value is 5, and the standard deviation is 4. So I did this problem by, you have the cumulative, what do we call it, cumulative normal, C norm, I think, in yours. What's wrong?
Sorry, what was the 0? 0.
So the probability that it's less than 0, is that right?
It said greater.
Oh, greater, sorry. Probability is greater than 0, I better write it down, so P of x greater than 0, well, that's 1 minus the probability of x right here less than 0. So that'd be 1 minus f of x. And then I put the value of x as 0. The mean value here is 5. And the standard deviation is 4. I mean, this is how I'm going to do it because I have that. And you have something equivalent to that. Now, he can actually put the limits of integration, so he can just go from 0 to that value. Now, make sure you can do this. This kind of problem is going to be on the quiz. And let me see what I got. I think I put these answers up there, but I don't remember. I got a point. Wait a second. Maybe I don't have that. What'd you get?
894, those,
Did I write it in there?
yes.
Yeah. 0.894. Has everybody got that? Did you get it? Are you having trouble with it, or? You got it or not? If you didn't, don't worry about it. I just want to make sure somebody's going to be able to help you. This is real important. You can do this. Everybody with me on this? What's the next thing?
The probability the value is greater than 0 but less than or equal to the mean value.
Okay. So really, what we're saying is this would be part A. Part B is the probability of x greater than 0, less than the mean value is 5, right? So I'm going to use he can set the limits. What kind of calculator?
36x Pro.
How many have 36x Pro? Here. Anybody else? Who? Here?
I think him.
All right, well, you can set the limit. The way I'm going to do this is basically take f of x of 5 minus really f of x of 0, right? Well, you all agree with that? And that's a cumulative. So for this one, I know I wrote the answers, and I calculated all these. I have this whole thing on math, and I don't have my calculator. All right, what is this equal to?
0.394.
Anybody confirm or deny that? You got it? Want to make sure that you can do it. It's real important. What's the next part?
The observed value is greater than twice the mean value.
So really what we're talking about for part C, I think we can all do this. Probability that x is greater than, well, 2 times the mean. If the mean is 5, is 10, right? Now we're getting at the hairy edge where we might have to use that approximation. Y'all follow me in this class? I think your calculators will get it. Here, let me see. Yeah, standard deviations for it. You can do this. This one, you're not way up there. So greater than 10, now the way I'm doing it is 1 minus f of x of 10. I'm just going to leave it like that. And I wrote down the answer.
0.106.
Is it 0.106? Check it. Anybody? You get that? Next problem. I'm trying to get these through. Go ahead. This is 2-5.2. Go ahead.
It's the fourth central and fourth moment for this
Central
variable.
for that problem above?
Yes.
Okay. So this is the fourth average, fourth central moment. That's 1 times 3. And then it's going to be times sigma to the 4th power. I'm just using the formula. Make sure you know that formula for even. Odd is 0. Everybody with me on this? If you take odd central moment, these are central moments, so you're subtracting the mean. Do you follow me on this one? This is even, so this is going to be 1 times 3, and sigma is 4 to the 4th times 4 to the, this is a big number. And I think the answer in the book's wrong. In the solutions manual. What did you get?
768.
What did I have? Did I have 768 in there?
You have
786.
Oh, all right. Maybe dyslexic. Let's try. Is it late at night? I was tired. I might have wrote it down. Scratch.
768.
Can you just scratch that? 768. I think the book is wrong on this one. What's the next part, the fourth central moment?
The fourth moment.
Fourth moment. Well, we could mess around with that, but no, forget it. The fourth moment of this one, the way he has it, I think it's 3. Hold on for 1 second. I know I've done these. Sigma to the fourth, yeah. I would give you this if I asked for this. Sigma x to the fourth plus 6, and it's going to be sigma x squared, x bar squared plus, and this is going to be x bar to the fourth power. So let's see what we get here. So this is a big number. Sigma x is 4, so it's 4 to the fourth. Plus 6 times sigma x squared is 16, and 5 squared, boy, 25. You're gonna have to help me on this one. Plus x bar 5 to the fourth. And I believe it's wrong in the solutions manual. They use the wrong values for mean and standard deviation. Because I looked at that. Y'all with me? I'm just using the formula. If I expect you to get a fourth central moment or fourth moment, I will provide this. That I promise you. But I just want it for completeness. Oh boy. So it's 16 times 16. Times 3 times that. Anybody?
I don't know if it's right, but I got 3,793.
I got that too.
3,793? Is that right? Anybody confirm that?
I can,
Huh?
I can confirm that, that's.
Okay, good. All right, now, next part.
The third central moment.
All right. We're not gonna, you know how to do it, right? Huh? It's, oh, third central, what am I saying? 0. Yeah. All right, 0. My bad. Go ahead.
And then the third moment.
That one we're gonna avoid. But if I ask you for these things, I'll provide it, all right? Fair? That's the end of that, right?
Yes.
Next, this is the one I wanted to get to. This is an inverse. So that's 2-5.3. If we get to the fourth one, which would be tricky, I love it, but.
Gaussian random current has a probability of 0.5 of having value less than or equal to 1.
Has 1/2 or 0.5 a value of less than or equal to 1. Listen to this. Can you read that again slower?
Has a probability of 0.5 of having a value less than or equal to 1.
Hear that? That tells you the mean value. That means the mean value is 1 on that problem. Did you look at this problem? It's perfect the way it's worded. So here it's 1. What else does he say?
It also has a probability of 0.0228 of having a value greater than 5.
Hold on. Greater than 5, right? And they asked for the standard deviation, I think.
As for the mean value, then
You got that. Mean value is 1.
the
Next.
variance.
All right, now the variance is something, this is an inverse problem, you follow me? You can do it on tables, but here's how I think I did this one. What I'm doing is something, they're saying that's the probability of having a value greater than 5, did you say?
Yes.
All right, so this is probability of I, or 5 first, and I being greater than that is 0.0028, right? Now, what I did on mine was basically say, well, if this is 0.0028, then the probability, and you can do it anyway, actually, this is the inverse problem. This is where it's trickier. This is a probability of 5 less than I, or I probability I greater than that is going to be 1 minus the probability of I less than 5. And that's 1 minus, for me now, f of x of so here's what I did. This right here is something where they give you this as 0.0228. You follow me on this? They give you that value. With me? Now this is an inverse. Can anybody follow me on this? They give you the probability, and they give you I here as 5, so I can put a 5 in here. Can y'all follow me on this one, class? So what I need is sigma x. Now this is an inverse, right? We've got this probability right here, and I can say if I take 1 minus this, it's f of x. Let me just do this here. So I can take 1 minus 0.0. This is how I did it, by the way. Let me see how you do it. Is equal to f of x of 5 comma 1 comma sigma x, and I want sigma x. So what I do is I go to that phi function, and I know that my phi here of u would be the integral from minus infinity to u minus infinity to u of 1 over the square root of 2 pi, and it's exp to the minus u squared over 2 d, I better call that u prime, du prime. And here u will be equal to I, which is 5, minus the mean, which is 1, over sigma x, or it's really 4 over sigma x, and I know that. So now now I'm going to do the inverse. This on my in MathCAD. Now your calculator is going to have values or have things. This function in MathCAD is equal to c. Careful about this. It's CFD. I wish I had my calculator. No, this is C norm on mine. I don't know what yours is. Now, C norm, and this would have an argument of whatever this is, and this, the mean value would be 0 and standard deviation 1. Now, if I had this value, which I do, I have this value as, whatever that is, 1 minus 0.0228. I can go ahead and use an inverse, so I have this value, and I can say, an inverse of this is called Q on mine. I want to find out what yours has. Q norm here, and the arguments for this one are going to be the probability, and then after that would be the mean value. And the mean value after you do this normalization here is 0, and the standard deviation is 1. So I put this value in here on mine, and I find that the actual value for this thing. Now it's normalized for x is going to be a value, or the argument I should say, of u equals, well, it equals 4. No, actually it's 2, pardon me, 2 here. And therefore, when I look at this, 2 would be equal to 4 over sigma x, or sigma x would be equal to 2. And I believe that's the, did I write that down in the book or not?
No.
But that is the correct answer. So what you need to do right now, and I don't want to leave you yet, is take a look at your calculators. And your calculators will have something where you basically can do the inverse of the cumulative distribution. And yours says INV, right? And yours, what kind is yours?
An Inspire.
That's a 36 or something like that, isn't it? An Inspire? I'm not sure actually.
Mine does, but it asks for sigma, so I don't
No,
know.
no, no.
I don't think it's.
No, what you can do for that one is this. I want to make sure we settle this now, because this is tricky. It'll give you a value of x, right? Just follow me on this. You agree with that? It will give you a value.
Oh, sure.
But if it asks for sigma, what you have to do is something. You've got to do this normalization. By the way, is yours something where you can put the limits of integration, or how is this thing work?
This one, it just asks for,
Is it
area
integrated
mean and sigma, area mean and sigma. So I
for
think-
probability?
Yeah.
Mean and sigma, right? And they give you an argument, but is that for an integration from minus infinity to that value, or from that value to infinity?
It's not, there are no limits, it's just.
Well, it has to have somewhere in the information.
I've got
Is, I think, please do this with me. If you have calculus, make sure you do this. So I'm going to assume that you have something that does this. I'm going to assume the forward search is this. X, here's the mean, and then here's the standard deviations. And the definition of this is going to go from minus infinity to this value x of 1 over the square root of 2 pi sigma of x, and then exp of minus quantity x minus x bar squared over 2 sigma x squared dx. Just, that's the standard. That's what I'm assuming we have, all right? Now, if we normalize, if we say, now we're going to use an argument u is equal to x minus x bar. We're getting rid of that over sigma x, right? I didn't say this, but if this is the forward, right, it would give you a probability p. Do y'all follow me on this one? If you actually had x bar, sigma x, and you wanted a cumulative distribution function integrated from minus infinity to x, it would give you a probability. You follow me? The area under that curve. Everybody with me on this? Now we have this. So for yours, let me get rid of this first. For yours, what you're going to do is an inverse. For the inverse thing, you're going to have some function. I'm going to use INV of f of x. And here, now you put the probability in, and you put the mean value, and you put the standard deviation. Yours is going to have something like that, and it will give you an argument for this, or basically x. Y'all with me? Now listen carefully on this. What we're going to do is use that idea, but we're going to normalize. We'll get this. Just watch. I want you all to do this with me. So here, I'm going to go ahead and I'm going to normalize this whole thing, and I call this basically, I'm going to have my phi of u will be equal to f of x, that exact function, but now I'm going to use u. Here the mean value will be 0 and the standard deviation will be 1. Y'all with me on this class?
Is it always gonna be 0 and 1 for the?
Well, this is normalized, so there's no mean. All right, the mean goes away because you have x minus, now I have to put this down. U is going to be x minus x bar over over sigma x. Y'all with me on this? Just hang on for a second. That would be the forward search. And in yours, the inverse search right here. So it's basically, that's what it is, but when you have whatever you call it, INV of f of x, which is the inverse cumulative distribution function of f of x, now you put the probability in, listen, the mean is 0, and the standard deviation is 1, and you'll get the argument for u. But that value of u will be equal to x minus x bar over sigma x. So would you do this for me? Everybody, because you're going to get a question on the exam or on the quiz about this. So please, everybody with me, you attentive here. I want you to go ahead, and if you, how many have the inverse function, right? I mean, all statistical packages, if you have a forward, you have an inverse. I don't know what that's called, but you say it on yours or not? You say it or not? Far back? You know, which kind of calculator?
This is the TI 84.
What?
I can look it up later.
If you got a laptop, you can look at, I promise you there's something, that there's an inverse. Do you have an 84 too? Can you show him?
Just inverse.
Now, I want you to take a look at this, and give me the value of u, just the value of u. I believe
It's 2.
2 or 4.
That was 2.
Are we using the?
No, it is 2. What am I saying? Yeah, you're right. So you get a u of 2. Just listen now. U equal 2. All right? That u is equal to, now look, it's going to be the value here. Think about what else. That was basically 5 was the value, right, that we're above, minus 1, because in other words, it would be x minus x bar over sigma x. We want sigma x, right? We know x was 5. Are you with me on this? X bar was 1. I could put I and I bar, but I'm just using x here, all right? So this is 2 is equal to 4 over sigma x, or sigma x is equal to 2. Y'all see that? All right, can you see it? Please follow me on this. Now look, here's how you confirm it. You got sigma x equals 2, right? On your calculator, we can do the integral right from 5 to infinity. On some, you have to, mine, the way I'm doing it, I take 1 minus that cumulative. Go ahead and take the cumulative distribution function. I wish I had a little more time. Now take a look at this. So if I want the probability of I being greater than 5, I know what that is. Let's see if my work confirms that. So that's going to be 1 for me now. It would be f of x of 5. The mean value is 1, and now the standard deviation is 2. And I should get 0.022, whatever it was. Is it 8 or something like that?
Yes.
Yeah.
So does it? Does it, Jagger?
Yeah, that's what I got.
Do you see it? Now, that's the kind of problem that will drive you nuts sometimes with tables. I'm just going to say your calculators will do this. And that's the reason I wanted to get to this one problem today. I'm going to do a few more on Friday. Friday, I'm also going to go through Rayleigh distribution. This is the stuff that drives you nuts. You got to be real careful about this stuff. And I'll give you hopefully some more problems related to this. So on Friday, come with a charge calculator, with a good night's sleep, hopefully, the night before. And the problems will be related to this, what we're doing. I'm not going to ask you higher order moments. Central moments, maybe. All right. But, I mean, these things can drive you out of your mind. And I'm the first to say, I didn't take a course, this is a junior level course, right? I did this as a senior.